All right, taking a quiz. Whenever we have class next, we'll take the quiz. So I'm looking at 10.1 and 10.2. Might help if you have your books open. We can go through, I can kind of go through and see, and we haven't really gone over the answers to these homeworks yet, have we? So this might be a good time to maybe ask some questions. We'll maybe do like one question a section. You know what I mean? Because they're not all exactly the same. But one question per section, and then we'll do it. What about 10.1? What did I give you for 10.1? Let me look at my notes. 1 to 29 odds. All right, so what do you want to do? You want to jump all the way to that?
No, just do
one from each section. Okay, 1 or 3, which one? Let's do 3. Let's do 3. All right, let's do number 3 because the answers come out a little bit weird, but really, it's not really much different. All right. Can somebody get that? Oops. This is why I use the straight line thing. All right. All right, so this is number 3 from section 10.1, and this is 6, and this is 13. I'll tell you right now, for the quiz, I will probably choose an even one, since I gave you all the odds, right? I don't want to give you one you've already done. That'd be boring, wouldn't it?
No.
So, but it'll be very similar to the rest of them, okay? So I'll probably pick the even one. So that might be something good to study, all right? But I might throw some odd ones in there too, so you never know. So what do we got to do? Find sine, cosine, tangent, and the cosecant. Why they picked the cosecant, I don't know, but that's all right. Okay, so find the sine of angle x, which is this one right here. This is z. This is y. Okay, so find the sine of x, the cosine of x, the tangent of x, and the cosecant of x. Really, after you do this one thing, the rest of it's super easy. All right, so what do we got to do? I'm finding the sine of this angle. So it would be the what over the what? Opposite over the hypotenuse. Problem is, we don't know the opposite. So we got to find the opposite. How do we find the opposite? We'll call it little x. Pythagorean theorem, okay? So it's going to be x squared plus 6 squared equals 13 squared. So that's what? 13 squared is 169. And then subtract 6 squared, which is minus what? 136. What's that? 133. Yeah? Take the square root. So x is what? Square root of 133. Weird looking number, but it's fine. It's an okay number. Just not our regular looking numbers. So now we got all 3 sides. That was the hardest part of that problem, was just doing Pythagorean theorem. Now, but you got to know the sine, cosine, and tangent. You got to know opposite over hypotenuse, adjacent over hypotenuse, and all that stuff, okay? So what is the sine of this? It's the opposite over the what? Hypotenuse. So it's the square root of 133 over the hypotenuse, which is 13. That's it. Don't have to do any math, really. Cosine is what? Of this angle. It's adjacent over hypotenuse. Well, that's kind of easy. That's 6 over 13. The tangent is the opposite over the adjacent. So the opposite is square root of 133 over the adjacent, which is 6. That's good. What's the cosecant? The cosecant is an inverse. So it's 1 over the what? It's the inverse of the sine. Okay? It's the inverse of the sine. So what was our sine of x? Square root of 133 over 13. So how do I find the inverse of that? It's 13 over square root of 133. Do any math teachers ever want you to leave it like that? No, almost everybody doesn't. Oh, is it? Oh, it is. Thank you so much. I was not looking at it the right way. And so they asked for the cosecant of y as well, correct? Okay, sorry about that. Thanks for seeing that. And we'll do that. Alrighty. So the cosine of y. So now we're going to this angle right here. So the cosine is what over what? Adjacent over hypotenuse. Okay, and well, the cosine of y, remember, the cosine of y would be the same thing as the sine of x, right? So you could always look at it that way as well, however you want to look at it. All right, so that wasn't that bad. Now the cosecant of y is still the inverse of the sine, but it's the sine of what? Y. All right, so let's find the sine of y. The sine of y is opposite over hypotenuse. So the sine of y would be 6 over 13. So what's the cosecant? It'd be the inverse of that, which is 13 over 6. There you go. Everybody good now? Yeah. So they actually made it a little easier than what I was going to make it, right? Because I was going to go, I tell you what, let's just do that one for the fun of it. All right, so let's do the cosecant of x. All right, what did we say would be? 13 over the square root of 133. You should be able to do this in your head at this point, can't you? Rationalize the denominator. So we multiply top and bottom by the square root of 133. And so you get what? 13 square root of 133 over 133. Yeah, that would be the cosine of x. Now, they didn't ask you that, but you never know. Okay, good. Enough of that. 4, 5, and 6 are kind of just like what we did, isn't it? All right, they just ask you the sine, cosine, and tangent. Actually, they ask you, the 3, which is just a sine, cosine, and tangent. Yeah, it's pretty much the same, so I'm not even going to worry about that. Let's do... this one. Like 7 through 14. So let's do an easy one. We'll do 7. Just start off really easy. You can use a calculator for this. It's the cosine of 12. All right, so let's bring out the calculator.
Is it in degrees?
I'm going to put it in degrees. I remember now to do it. What is it? Mode, right? Yeah. Put it in degrees. Hit enter. There we go. All right, the cosine of 12. Super easy. Hit cosine, hit 12, and then boom, there it is. 0.97 it says, round to 4 decimal places. So if we're going to, technically we should put a squiggle, but I'm not going to mark it wrong if you don't. So it's 0.9781. Does that 4 round the 1 up? Nope, so it just stops at 1. So it's 0.9781. Easy. What about number 8? Do the next one. Number 8 says the cosecant of 38 degrees. Now, you don't have a cosecant button on here, do you? But you do know that the cosecant is what? 1 over the sine of 38. So that's what we're going to put into the calculator, is that right there. So you had to know a little bit, besides just punching a number in a calculator like number 7. So you had to know this. So what are we going to do? 1 over, 1 divided by the sine of 38. So sine 38. And then, boom, there it is. Is that right? 1.6243. Yep. And it is a 3. Why is it a 3? Because that 6 rounds that 2 up to a 3. So it's 1.6243. And that's how you do that. We good? All right. What about one of the ones, it looks like you got minutes and seconds and all that good stuff. Let's do one with seconds in it. Let's do number 13. 13. So the cosine, who's got that open? Read it off to me. 14 degrees, how many minutes? 20. And then seconds? 15? Okay. Oops, that's seconds. This is minutes. So it's 20 minutes, right? Okay, 20 minutes, 15 seconds. All right, so what we got to do before we put this into a calculator. Now, there are calculators, and I think this one has it too. I forget. They show you in here, I believe. Is it alpha? Well, where they change it from degrees. It's like a DRG. It's like degrees. Is it DRG? It's DM. No, DMS. Degrees, minutes, seconds. And I think it's in one of these. Because I never use this, all right? I'm going to show you how to do it without just sticking into a calculator. But is it under math? No, I don't think it's there. Has anybody done that? Some calculators have a, what do we say it was? DMS, right? Some calculators have it written on the front somewhere where it says DMS. I think on this calculator you have to go somewhere. It's one of these second apps. Where's that at? Where is it?
It's next to
Is it right in front of me? I can't even see it. Is it on the white or is it behind the app? Oh, right here. The blue one. Okay. There you go. There's DMS. So you go down and you hit 4. How do you use it? Have you used it before? Have you used this before?
Yeah.
How do you do it? You clear it first? Because what it's doing is taking that answer. Yeah, I'm trying to take this and turn it into a decimal. So I want to take 14 degrees and use that DMS button. So it's second function apps, right?
Yeah.
Do you hit the DMS first?
No.
Okay, you got to put a number in there first. So you hit, what do you hit? 14?
14 and then put second apps.
Oh my gosh, I could probably do this easier.
And then 1.
Oh, okay, 1 for the degrees. Okay, I gotcha. And then 20, and then second function apps 2, right?
Yeah, and then the
And then-
seconds is the plus sign.
So you don't just put the seconds in there like we did earlier with them.
You just type the number and then do alpha plus.
Is it alpha?
Alpha.
Is it? Well, but why isn't it this?
Because
Oh, it doesn't have it in there. Oh, that's weird. Okay, so what do you do? Hit alpha.
alpha and then the plus sign.
Man, how confusing could they make that? Is that little thing right there? Seconds?
Yeah.
Doesn't look like second. That looks too big. Okay. All right, and then you hit enter. All right, there we go. Man, that was confusing. I mean, if you do it a while, it shouldn't be that big of a deal. But how can you do it if you didn't know all that stuff? What if you didn't have a calculator that had DMS on it? Because a lot of calculators don't have that on there. So what would you do? Well, you just take 14 plus, and you take 20, and what do you do with that 20? Divide it by 60, plus what? 15, divide that by 3,600. All right, and you should get the same exact number. Okay? So it's 14 plus, tell you what, I'm going to put this in parentheses. I don't know if you really need to or not, but I'm going to. Divided by 60 plus 15 divided by, oh, I should have put parentheses around that, shouldn't I? So 15 over 3,600. Close that parentheses, and there you go, same number. Tell you the truth, I think it's just as easy doing this, don't you? Then remembering to go to second function in apps, and then you got to go to alpha, and then to this other thing. To me, I think it's just as easy. I would not say it's easier, but I would say it's just as easy to do that in your calculator. You should be good to go. All right, we go to that. And then 15 and 16, they asked you to use a calculator to convert. Yeah, don't worry about that. We already did it on this problem, so I'll probably just give you one of those problems right there. Oh, by the way, sorry. You got to do what? What was the question actually asking you to do? Let's find the cosine of this thing, right? Not just changing it to degrees with decimals. So we got to find the cosine of this. So, Lily, you seem like you know about your graphing calculators. Oh, answer right there. Okay, so watch. If you hit cosine of the answer, see the last thing that's in there, 14 point. You could just type in 14.3375, or you could hit second function answer. Do you see that? It doesn't actually show you the number, but it's actually putting in 14.3375, and then you hit enter, and then there you go. That should. Let me just double check, make sure. Oh, I flipped the page. Let's make sure it is that. Yep, it's exactly right. And again, round it to the fourth place. 1, 2, 3. This is 4. That 5 rounds add 8 to a 9. So technically it's 0.9689. So this is equal to 0.9689. That is your answer to number 13. Okay? All right. Let's move on. I think we're finally getting close to the one you asked about. Did you ask about? So now did you ask what, 19? Is that the one you asked? Okay. Was it 19? Okay. Did you figure it out already or no? All right, so let's do number 19. It's a right triangle. And what do we got? 8 and 12 right here. And here, LNM. LNM. Alrighty. And it says state the 3 basic trig ratios for each acute angle. For each acute angle. So we want to find them for angle, whoops, let's try this again. For angle L, looks like angle, but anyway, that's angle L and angle M. Right? We're going to find the basic 3. So we're trying to find the sine of L. We're finding the cosine of L and the tangent of L. Zanai, did you understand what you're trying to find? Okay, sine of M, cosine of M, tangent of M. All right, so now it's just a matter of, now look, again, just like that first one we did, they only give you 2 sides, right? So you got to find that third side. So how do you find that third side? We'll just call it x. So it's x squared plus 8 squared equals 12 squared. Oops. Right? That's 144 minus what? 64? Oops, can't write today. What's that? 84? 80? I'm sorry, 80? Did I do that right? No, that's not. Oh, square root. Square root of 80, right? And they probably write it with square roots, don't they? Right. I'm saying they're going to simplify it, but I was just making sure that that's what they're doing here. Yes. Okay. So square root of 80. So we have to do a little bit of extra work. Remember that square root of 133? That you couldn't simplify that, so we just kept it that way. But what about 80? What times what is 80? Okay, 8 times 10. Okay, that's good. We could break down 8, right? So that's what? 4 times 2. And then 10, you could break that down into 2 times 5. Well, there's another 4, right? So really, what is it? It's 4 times 4, which is 16. What's the square root of 16? It's 4, what? Square root of 5. Can you do that? Because 16 times 5 just didn't, well, it kind of did, but I didn't say it did. Normally, it doesn't pop into your head. 16 times 5 is 80. Would you agree? All right, but you could always just break it down like this. So it's 4 square root of 5. So, oops, right on my cord here. X is 4 square root of 5. All right, so let's do this thing. We kind of did this already today, but let's do it again real quick. So the sine of L is opposite over hypotenuse. So it's 4 square root of 5 over 12. But we got to do something here. What do we got to do? 4 goes into both of them, over 3. Everybody see that? 4 goes into 12 3 times. So that's how they would write that. We good? Cosine of this right here is adjacent over hypotenuse, which is 8 over 12. Reduce that. 4 goes into both of those, right? 2/3. Okay, opposite over adjacent. So we've got 4 square root of 5 over the adjacent, which is 8. Simplify, right? 4 goes into that once. 4 goes into that twice. So it's the square root of 5 over 2. Now, what can we do over here? The sine of m would be the same thing as what? Cosine of L. So really, save you a little bit of work. Just understanding that. Agreed? The cosine of m is the same thing as the sine of L. So it's the same thing. It's not an inverse. It's just the same thing. Square root of 5 over 3. You could always do the opposite over hypotenuse and adjacent over hypotenuse if you wanted to with angle M. But you're going to end up with the same thing. What's this going to give you? It's the inverse. The tangent of M is the inverse or the reciprocal of tangent of L. So what's that going to be? 2 over square root of 5. But we don't want to leave it like that. So it's 2 square root of 5 over 5. And there you go. It was very similar to number 1, or not number 1, whatever the first one we did today was. Number 3, I think it was. But they did some added stuff to it, right? You had to simplify the square root of 80. Then you had to simplify some fractions here. Other than that, it was kind of like number 3. But it definitely had a couple extra things you had to do. Does that help? Okay. All right. On this, from this section? Sure. Yeah, let's skip 20 and 21. That's just calculator work, right? That's just finding the sine, cosine, tangent of these angles, finding the sine, cosine, tangent of the complementary angle, right? So that's not that big of a deal. 22 to 27, definitely want to talk about that. What did I give you? Up to 29? Oh, okay, now I know why. I'm going to give you 29. All right, so let's do 20. Let's do 20. Let's do one that I gave you to do. Let's do 25. 25. All right, so it says cosine of theta is equal to 15 over 17. But what do they ask you to do here? It says find the other 5 trig ratios. So what I'm going to do is I'm going to just draw a little right triangle. It doesn't have to be to scale. I don't really care. All right, we'll call this angle theta. Now look at what this is. The cosine of theta is 15 over 17. So that means it's the cosine, so this would be the adjacent, and this would be the hypotenuse, right, to this angle. So what side's going to be the 15? This side right here. What side's going to be the 17? The hypotenuse. That's going to be right there. This is a Pythagorean triple, isn't it? 8? Is it 8? 15, 17? I think it is. Yeah, I think it's 8. So if you can remember your Pythagorean triples, I'm just saying, if you can, do you see how much easier it is just to say, oh, that's 8? Doesn't always work that way, but in this case it did. All right, but you could always do Pythagorean theorem. I'm not going to do that. We've done it twice already. So, but you'll get an 8 out of that. And they just asked for the other 5. So they already gave you the cosine. So you just have to find the sine, okay, and the tangent. All right, and then you had to find the what? The cosecant, all right, the secant, and then the cotangent. And that should be pretty easy. It's like the 3rd time today we've done this. All right, so the sine is opposite over hypotenuse, 8 over 17. The tangent is opposite over adjacent, 8 over 15. The cosecant is the inverse of the sine. So if the sine was 8 over 17, what's the cosecant? 17 over 8. Right? It's just the inverse, the reciprocal of it. The secant is the reciprocal or the inverse of the cosine. So if the cosine is 15 over 17, what's the secant? 17 over 15. See how easy that is? Yeah? Cotangent is just the reciprocal or the inverse of the tangent. That was 8 over 5, so this is 5 over 8. And then you're good to go. Yes. Are we okay with that? So setting it up was the important part to this, and knowing what side was 15, what side was 17, then you got to find the third side. Does everybody understand why this was 15? Because it's the cosine, it's the adjacent over the hypotenuse. So that's adjacent, that's hypotenuse. That's where you put those numbers. Yeah, it's pretty simple, isn't it? And let's do 28 or 29 or 30. I don't care. Which one? Pick one. Still got to do another lesson, though, don't we? When are we out of here? 14? Why do I always run out of time? Because I talk too much. 28? All right. I'll just draw this by hand. Oh, that's pretty ugly. This is A, B, and C. And you said 28? It says find the cosecant of A if B is 21 and C is 29. All right, so we got a little right triangle here. And there we go. So there's angle A. First of all, what's the cosecant? Cosecant goes with what? With the sines, the inverse of the sine. So it's 1 over the sine of the angle. All right. So what is B? That's 21. C is 29. Can we find the sine? Because that's what we want to do really first, is find the sine of this, and then we take the inverse. I can't because the sine is the opposite over the hypotenuse, so I got to do some Pythagorean theorem. Does that actually come out nice? I think it does. I think it's a 20. Anybody do this one? Nobody did it? What's that? Oh, it's an even. That's why you didn't do it. Okay. I'm pretty sure it is, but let's just do it anyway. A squared, or we can just do this. Who's got a calculator with them real quick? Anybody got it out? What's 29 squared? So it's going to be 29 squared, which is what? 841. Okay. You're talking right in the back of her head. That's why I can't hear you. Okay, 841. And then we're going to what? Minus 21 squared. What's 21 squared? 441? Okay. 441. Oh, I should be able to do that. 400, right? Take the square root. That's 20. Yeah, check it out. Another Pythagorean triple, right? 20, 21, 29. Thought it looked familiar. Don't use that hardly at all. So I didn't really remember it was 20, but I looked at the answer thing, and they had a 20 in there, so I figured it was a Pythagorean triple. And it was. So what do we got to do? Let's find the sine first. So it's 1 over. The sine of A is what? Opposite over hypotenuse. So it's 20 over 29. So what's the cosecant of A? It's just 29 over 20. And there you go. Does that make sense? Yeah. This trig stuff's actually kind of easy, don't you think? Once you learn how everything works, it's really not that difficult. There's not like a million steps to these, at least not right now. Okay. Later on, it's going to get a little crazy. But for right now, it's been pretty good. All right, let's look at 10-2. What do we have to do with 10-2? Let's solve the right triangles. Yeah. What did I give you on that? 1 to 23? 24? Oh, I gave them all right. That's right. Well, let's just do a few of these. They're all kind of the same, aren't they? I'll tell you what. Let's go right to the ones where they ask you to solve the whole triangle, because that's what I'll probably give you on the quiz. Solve each right triangle. If you can do these problems right here, 15 through 18, you should be able to do any of them from that section 10-2. All right? So let's do it. All right, so there we go. And ABC, A, B, C. All right, 15 through 18. Let's do 15. That's an odd problem. That's one of the ones you had to do. So A, angle A. So when they put capital A there, automatically that means an angle. Plus they put the degree symbol, so that's a pretty good indication that that's an angle. And then B is, B is 5. Okay, so let's put them in here. So that's 5. Angle A. Which one's angle A? This one right here. Why? Because it's opposite side A. So that's 38 degrees. Okay? And we got to solve for the whole triangle. We got to find the whole triangle, correct? Yep, solve each right triangle. And that's the only thing they give you, those two things. So let's, well, we can find this angle right here, couldn't we? That would be angle B. That would be super easy. How do you do that? Yep, subtract it from 90. So that would be what, 52? So this is 52 degrees. So that's one of my answers right there, degrees. And let's do the other side. So let's find A. Okay, find A. So which trig function am I going to use? That's the big question. Well, I'm trying to find A, so that's opposite. What side do I know? I know adjacent. So which one has opposite and adjacent? It's the tangent. So I'm going to use the tangent. Tangent of that particular angle. I could have used 52 if I wanted to, right? But just use the one they give you. Is equal to opposite over adjacent A over 5. Multiply both sides by 5. I'm not going to take the time because time's running out. Stick that into a calculator and you get whatever you get. And they said it's about 3.9. And they ask you to round it to the nearest tenth. Okay, so everything's rounded to the nearest tenth. All right, so that's rounded. And then side C, I got adjacent and I got hypotenuse. How would I find C? Use the cosine of the angle. 38 degrees equals adjacent, which is 5, over the hypotenuse, which is C. Now watch the algebra here. It's just one little extra step. Once you get used to these, it's really not that big of a deal. If I want to get C by itself, I want it on top too, right? I don't want it on the bottom. I want it on top. So I'm going to move it over here to the left. Now I have to get rid of that cosine of 38. How do I get rid of that? Move it to the right by dividing it. So what am I left with? 5 over the cosine of 38 degrees. Put that into a calculator and you get approximately 6.3. And there you go. You just solved the triangle, right? You got all three of the missing parts. Oh, yeah. This is 6.3. Everybody good? And this is 3.9. Really, if you can do that, you should be good. Yeah, let's do that. It's a special triangle. It's a 30, 60, 90 triangle. And let's see, would you say 22? 60 and 4, right? 60 degrees, and that's 4. And I think that's all they give you. Yes. Okay. So, do you remember the relationships on a 30, 60, 90 triangle? This is your short side right here, okay? This is your long side. What's the first thing I can find very super easy? If I know, yeah. Well, let's see. Well, you got to find the short side. This is not super easy. I was thinking the 4 was the short side. I was mistaken. Okay, this is the short side. This is what we want to find first. So how do we find the short side? Well, the long is equal to what? The square root of 3. Oh, come on. Square root of 3 times the short. So if I'm trying to find the short, what am I going to do? I'm going to take the long and do what to it? Divide it by. So this is going to be 4 divided by the square root of 3. Let's write it nicer though. What's it going to be? 4 square root of 3 over 3. So that's what this is going to be. 4 square root of 3 over 3. Okay. Now, how do I find the hypotenuse? The hypotenuse is what? 2 times, I think if I write too fast, it really messes up. I don't know why, but I got to write fast. I got to get done. All right, so the hypotenuse is twice of this, so really super easy. What's that going to be? 8 square root of 3 over 3. And then there you go. That's your answer. There and there. Make sense? And this as well. Okay, they asked for that. Do we have any time? Not really. That's pretty much it. 45, 45, what's the relationship between on a 45, 45? Whoops. Yeah, the legs are the same. The hypotenuse is what? Yep, come on. Equals the square root of 2 times either one of the legs, because both the legs are the same. All right, so you kind of do the same thing, but your relationship's just a little different. So there you go. That's plenty of stuff to put on a quiz, isn't it? Yeah. Yeah, sir. Okay. It won't be on the quiz. It's just this. I don't know exactly what they want you to do for that. They don't really give. Oh, I see what they do. They do this. Now, hang on to the homework. Use that to study from. I'll collect it whenever. Apparently, we don't have class tomorrow because we got that senior thing. So I guess, what, Friday? What's tomorrow? Thursday? Yeah, so probably Friday I'll collect it. Just put it in a place. Don't lose it. Put it in a folder or something. Use it to study from, though.
Ask questions.
Yes.
For the quiz or something.
Which one?
Do I need to write more
Which one are you talking about?
For example, this one.
Oh, yeah. Yes, you do have to. So,
Write like that one?
yes, you have to write it like that. Yep, you do not want it like that. You must write it like that. Okay? It's technically the same number.
Yeah,
but like if you had like 2/4, your math teacher would never let you keep it 2/4. Would you agree? Even in Japan, they wouldn't let you keep it 2/4, would they? What would every math teacher you ever had make you write your answer like?
Yeah.
Like that, right? Okay, so it's the same way with this. All right, so even though they are equal to each other, it's true, but we want you to write it like this. Okay?